This conference will now be recorded.
Okay, good afternoon, students. I will wait 5 minutes, let them to join. Okay, students, what we discussed in last class? Students, are you hear my voice? Right. So today we are going to discuss one model problem that is based on what we discussed in last class. That is optimum generation with including the transmission losses. So based on the derivation, we are going to solve one model problem in today's class. So all of you just we have with paper and calculator with you. So today class we are going to solve one problem that is based on optimum generation allocation including transmission losses. So first of all, just note down this question. So this is the question. So this like this, you will get an external exam. So if they ask the question based on that, including transmission losses, the question should be like this. Just note down this question. So I mean, these three equations and this limits, and this is the so if they're including that, so they won't mention that whether this problem belongs to that including losses or not including losses. If they're giving this equation like this, it means that that is power loss equation. So it means that it belongs to that optimum scheduling with including transmission losses. And the system load is 150 megawatt. So after not only this a question, just give the message after completion of this question. So మీ స్క్రీన్ పైన ప్రాపర్ క్వశ్చన్ కనబడుతుందా? Are you able to see this question on your slide? Right. So just note on that what the that three equations C1, C2, C3 and the three limits power loss equation. So so it surely you will get one model problem on this these three methods. So what we discussed up to now. That is first one normal traditional method. Second one is not including losses, and third one is including losses. So surely you will get one model problem on this. So after completion of this unit, we will discuss previous question papers. Then only we will get idea of which topic is most important from the first unit. So the power loss equation is 0.0218 P1 square. So these are on the per unit values plus 0.0228 P2 square plus 0.0179 P3 square. Where the loss coefficients are specified in per unit on 1000 MVA and the total demand is 150 megawatts. What is the maximum capacity of these three plants combinedly? What is the maximum capacity of these three plants combinedly generating? I'm not asking load. Maximum capacity అది ఎంత వరకు జనరేట్ చేయగలుగుతాం మూడు కలిపి త్రీ ప్లాంట్స్ వచ్చేసి ఎంత ఐఎమ్ ఆస్కింగ్ టోటల్లీ త్రీ ప్లాంట్స్ how much power generate maximum power generate by using these three plants to combinedly, right? 235. So why? Because you have to consider that this is the maximum demand. So maximum power generation and minimum. So 85 plus 85, 165 plus 70, 235. So 235 megawatts is the power capacity of combinedly these three units. But it has to be generate 150 megawatt. That is a low demand. Now out of 235, there has to be combinedly generate 150. Instead of 150, what is the contribution of C1, C2, that is a plant 1, plant 2, plant 3, and what is the total cost of the entire three units? Let me discuss, let me find that. నోట్ చేసుకున్నారా? So after note down the completion of problem, just tell me that. Right. See, in this problem, first of all, you should have to know that what are the formulas we have to use and what are the steps we have to find the upcoming, that is our requirement of parameters. Right. So these are the formulas we have to use that while solving this entire question. The first step is first we have to assume lambda equals to some value and substitute here. Already we have that beta gamma value in this problem. But after that, if you find this value b1, we can calculate b1, b2, b3. So after that, what we have to do after finding that p1, p2, p3? See here, this is just not on this four formulas. This is have to be find that P1, P2, P3. After finding these three values, you have to substitute in this power balanced equation. If it is becomes to zero, then the lambda value is finalized. If it is not equal to zero, we have to update the value by using this formula delta lambda. Here delta p power k can be obtained from this value and the denominator we can obtain from here. So now what we have to do means from the given data, that is C1, C2, C3, write on that alpha 1, beta 1 and gamma 1. Similarly, alpha 2, beta 2, gamma 2, alpha 3, beta 3 and gamma 3. Write down these 9 parameters. So here alpha 1 equals to 200, beta 1 equals to 7, gamma 1 equals to 0.008. So write down these 3 parameters. Similarly, alpha 2, beta 2, gamma 2. Alpha 3, beta 3, gamma 3. Alpha 2 is 180, beta 2 is 6.3, gamma 2 is 0.009. Right. See, after find the value, generally, if you observe this question, the all parameters are measured represented in the megawatts. That is limits itself for that may have load. But the loss is in the form of per unit. How we can convert this per unit value into megawatts? Do you have any idea? So this power loss equation in terms of per unit, right? So how we can convert this per unit into megawatts? How we convert per unit to megawatts? Here already given MVA base value. See how we can convert means just consider this equation. See, just substitute instead of P1 equals to P1 by 100. So you will get 0.0218 into P1 by 100 whole square plus 0.0228 into P2 by 100 whole square plus 0.0179 into P3 by 100 whole square totally into 100. So if you did like this, then you will can convert per unit to megawatts. So I will show you what you will get after conversion of this per unit to megawatts. Right. See here, this nine out of parameters what we got from the given equation C1, C2, C3. Now, if you see this, the power input is expressed in the megawatt. Therefore, the real power loss in terms of megawatt generation is. So, generally, if you, in the power balance equation, the all parameters represent the megawatts. But in our problem, the power loss is given in per unit value, and they mentioned as it has that 100 MVA value, right? So what is the amount of MVA they will give? You have to write like this. So 0.018 instead of P1, you have to write P1 by 100. If they give 1000 means P1 by 1000 MVA, 1000 whole square like that. So substitute instead of P1 is by P1 by 100 whole square and finally into 100. Why? Because the percentage, the per unit value is always shows in the percentage. So 0 point something, 0.02 per unit like that, right? So you have to multiply with 100. Now in this power loss equation, This first term represents that B11. Second one is B22. Third one is B33. So you have to convert all power loss equations in megawatts. That is the first step we have to solve this. See, after finding this power loss equation, we have to proceed that remaining procedure. First, we have to assume the lambda value. In this problem, I am considering lambda equals to 8. So how we can assume lambda equals to 8? So we can assume 6 or 7, whatever it may be, right? So ఎందుకు నేను 8 కన్సిడర్ చేసుకున్నాను ఇక్కడ? Why I chosen as lambda equals to 8? సో ఎవరికైనా డౌట్ వచ్చిందా ఎందుకు లాంబ్డా వాల్యూ 8 తీసుకున్నాను? So why we are choosing lambda equals to 8? See, after substituting of after finding the power loss equation, we have to proceed that problem by assumption of lambda equals to 8. So అదే నేను అడిగేది why we will get 8? Why we are choosing? So ఎలా అంటే just see here, if you see this beta value, what is the maximum value here? 7, right? So you had to choose that lambda value that should be more than that among these 3 values. Okay na? So ఇందులో maximum ఏముందో ఆ వాల్యూ కన్నా ఎక్కువ వాల్యూ తీసుకోవాలి లాంబ్డా వాల్యూ. కావాలంటే మీరు లాస్ట్ ఫార్మ్ చెక్ చేసుకోండి. సో లాస్ట్ ఫార్మ్ మనం లాంబ్డా ఈక్వల్స్ టు 6 తీసుకున్నాం. ఓకేనా? So 6 means the beta values in this problem it is less than 6 value. So 5.5, 5.2, 5.8 ఆ విధంగా వచ్చింది కాబట్టి we are choosing that lambda equals to 6. And here the maximum value of this beta values, the maximum value is 7. So we have to consider that lambda which should be more than that maximum value. So that's why I'm choosing 8 here. Are you clear? How we can choose the lambda value? Right. See now find that P1, P2, P3 by using this value. So by using this value find that P1. So if it is P1 means, so this is the first iteration. So on first iteration we are assuming that lambda equals to 8. So if it is first plant, then you have to consider lambda iteration, that is power k is iteration minus beta 1 first iteration divided by 2 into gamma 1 plus 8 into beta 11. So this is the formula we have to find that P1, P2, P3. So this is the way of you are substituting that P1, P2, P3 for first iteration, second first iteration. So we have to mention power 1 like that. So the power indicates that iteration number. And this B11, B22, B33. So we obtained from the power laws equation. Power laws equation, it can be represented as B11 P1 square plus B22 P2 square plus B33 P3 square. So just keep the fixed value in your calculator is fully. సో ఫిక్స్డ్ వాల్యూ పెట్టుకోకండి, కంప్లీట్ చేసుకోండి. ఫిక్స్డ్ వాల్యూ 8 కానీ 7 కానీ పెట్టుకోండి, ఎందుకంటే మీకు ఇన్ని డెసిమల్స్ వాల్యూస్ వస్తాయి. సో జస్ట్ కీప్ ఫిక్స్డ్ వాల్యూ is 8 or 9, then only you will get that accurate value. Have you all found this? See, after these values, just find the PL value, that is power loss. So power loss equation is so in that equation substitute in terms of instead of P1 square, P2 square, then find the PL value. After finding this P1, P2, P3, find the PL value, that is power loss formula. So tell me the value of PL. What is the value of PL? After substituting the value of P1, P2, P3 in last form, power loss formula equation, then you will get the total value of PL, that is power loss value. So its value is PL, right? PL. What is the value of this one? Suresh, 201.0003. So don't fit that decimal values in fixed value. So just leave it that. So you have to keep that 6 digits. Keep the 6 digits as a fixed value. So that is your power loss value is wrong. So you will get power loss value is 2.886. So this is the value of power loss. Have you all got this value? సో నో ప్రాబ్లం ఎందుకంటే మనకు ఈ ప్రాబ్లం చాలా ఇంపార్టెంట్ నిదానంగా చేయండి. So you have to get power loss value is 2.886. So keep your fixed value is 6 digits in your calculator. See the power loss value is 2.886. So that is the power loss value. So after finding this power loss formula, what we have to proceed? So now we have the values PD is equals to, that is power demand equals to 150 megawatt, and PL, that is power loss value equals to. So just note on that what you got power loss value. So I got like 2.886, and the power balance equation delta P is equals to PD plus PL minus sum of P1 plus P2 plus P3. Find the delta P value. Delta P power 1, that is first iteration. So what is our requirement of condition? The delta P should have to come 0. If it is not becomes 0, then we have to update the lambda value by using delta lambda. Find the delta P value. Right. Minus 48.1143. Minus 47. Okay, no problem. So మీకు ఏ వాల్యూ అవుతుందో ఆ వాల్యూ పెట్టుకోండి. What about others? So the delta value we are getting that minus, so it is not zero, right? So we have to update the lambda value. So what is the formula we can use for updating the lambda? D lambda delta lambda equals to delta p power k divided by summation of I equals to 1 to n. So what is the formula? dpi by d lambda. So this is the formula we have to use to update the delta lambda. So let me see how it will come. So ఇంతవరకు చేశారు కదా. So this is the error. So that is when if you substitute that all values, that is power demand, power loss value and P1 P2 value, then finally you will get that delta P is equal to minus 48.1139, but it is not equal to 0. It means that it is required to update the lambda value. So let me see how we can update the lambda value. So this is the formula for updating the lambda. So delta lambda is equals to dp power k divided by summation of I equals to 1 to ng dou pi by dou lambda. So first denominator find out change. So denominator we can find by using this formula. So we have to expand this. So we have three plans, right? So I equals to 1, I equals to 2, I equals to 3, like that. So you will get expansion like this. So this is the term is belongs to the denominator, not numerator. So this is the lambda value updated value, and here the numerator is already you guys have got, that is power balance value delta p. So value is delta p divided by and this expansion. So చేస్తే మనకు ఈ విధంగా వస్తుంది. సో మీకు ఏదైతే వాల్యూ వస్తాయో అయ్యే సబ్స్టిట్యూట్ చేసుకొని చేయండి. So why? Because that value should be changed based on your fixed value. So somebody will fix the 5 digits, 4 digits, ఆ విధంగా ఫిక్స్ చేయడం వల్ల మీకు వాల్యూ డిఫరెన్స్ వస్తుంది. సో నో ప్రాబ్లం, మీకు ఎంత అయితే ఆన్సర్ వస్తుందో సేమ్ అదే సబ్స్టిట్యూట్ చేసుకుంటే వచ్చేయండి. See, after substituting that numerator denominator value, we got minus 0.31552. Now this value has to be subtract from 8. Then we will get lambda equals to 7.6845. This is the new value, and this value has to be used for the second iteration. So in second iteration, same process will be happening here. So just find that by using lambda equals to this value, find P1, P2, P3, PL. So by using this all, find the delta P for second iteration. So if I was purchase చెప్పండి. సెకండ్ iteration స్టార్ట్ చేశారా? So what is the values of P1, P2, P3 second iteration? So for second iteration, P1 is 35.37, right? 64.38. So P3. So 35 point. P3 is 52.80. So this P3 value wrong వచ్చింది. Sorry. So P3 value is 52.8015. ఓకే స్టూడెంట్స్, మీరు ఈ ప్రాబ్లమ్ ని ప్రాక్టీస్ చేసుకోండి. సో మీకు మాక్సిమం ఈ ప్రాబ్లం వచ్చేసి 4th ఇటరేషన్ దగ్గర ఎండ్ అయిపోతుంది. సో దిస్ ప్రాబ్లమ్ విల్ ఎండ్ అట్ 4th ఇటరేషన్. సో 4th ఇటరేషన్ లో మనకు అప్డేటెడ్ లాంబ్డా వాల్యూ ఏమొస్తుందంటే 7.6789. సో when the lambda is equal to 7.68 sorry 6789. So 7.6789. So when we lambda value is this value, then you will get that the power mass equation equals to 0. So you will get up to 4th iteration. So a problem practice చేసుకోండి. So we have remaining 2 topics from the first unit. So within this week I will going to complete this first unit. So after that we will discuss that what is the questions asked from the previous question papers. So after the discussion of the papers, and we have to be write first slip test on unit 1, right? So మీరు ఈ ప్రాబ్లం ప్రాక్టీస్ చేసుకోండి. సో ఆల్రెడీ మీకు మెటీరియల్స్ గూగుల్ క్లాస్ రూమ్ లో అప్లోడ్ చేశాను. సో యూ కెన్ గెట్ ఫ్రమ్ దట్ అండ్ జస్ట్ ప్రాక్టీస్ ఇట్. Okay students, I'm going to end up this session. Just practice. If you have any doubt, ask me, I will clarify that. So in tomorrow class we are going to derive one more derivation that is belongs to that transmission loss formula.